Our today's topic is states of matter that will be explained on the basis of kinetic particle theory. Kinetic particle theory states that all matter is made up of composed of tiny particles that are always in motion. This theory explains the states of matter as well, but first of all we should know that what is matter. So matter is any substance that has mass and takes up space by having volume. So there are three states of matter: solid, liquid and gas. Again, what is matter? Matter is anything that has mass and space. So let's discuss the three states of matter. What are the differences between them? First of all, we talk about solids. That in solids the particles are closely packed. And why are they closely packed? Because there are strong forces of attractions holding these particles together. That is why the particles are very closely packed, um, because of these very strong forces of attractions which are present between the particles. As a result of it, they cannot move here and there. So what they can do is just they vibrate at their fixed positions. So this is how the particles of the solids can move. As we have said that in kinetic particle theory, according to that theory, matter is made up of tiny particles, and these particles are in a state of constant motion. So in the solids, as the particles are very closely packed, that you can also see in the diagram over here, the particles are arranged in an orderly manner. So these particles cannot leave their places. So what they can do is that they just vibrate at their fixed positions. In the case of liquids, you can see in the second picture, in the case of liquids, the particles are loosely held, but still the particles are just touching each other. These particles can move past one another. That means that they can slip and slide over each other, but they remain touching one another. In liquids, there are strong forces of attractions between the particles, although they are less as compared to solids, but still the forces of attractions are strong in liquids. As the particles can slide over each other, so um, that's the reason that the liquids can flow. Next is gas. In the case of gases, the particles are far apart from each other. As the particles are far apart from each other, you can see in the diagram as well, the third one. In the case of gases, the forces of attractions are so weak that we can say that they are almost negligible, or very weak forces of attractions are present between the particles, and the gas particles are free to move about. They move they move randomly in all possible directions. Now let's discuss few properties of matter. For example, we can discuss the shape, volume, compressibility and fluidity. First of all, let's talk about solids. As we have said that in solids, the particles are arranged in a definite, they are closely packed. So that's the reason that solids have a definite shape as well as definite volume, because the particles are very densely and closely packed. As these particles are closely packed, so there are no gaps. That's the reason that we cannot compress the solid particles even closer. We can't do it because there are already no gaps between the particles. And as the particles are held together by strong forces of attractions, they cannot leave their places, so solids cannot flow. In the case of liquids, as we have just said that in liquids the particles are loosely held, that's why liquids do not have a definite shape and they take the shape of the container, but still the liquids have a definite volume. Like if you say 500 ml, so what is 500 ml? It's a quantity that represents the volume of liquid. If you say I have 500, if you say that you have 500 ml of water. So 500 ml is the volume of the liquid. Liquids are also, as there are very small gaps between the particles, so we can say that they are just slightly compressible, or it's very difficult to compress liquids. So almost they are also not compressible, but or you can say that they are slightly compressible. Now, as the liquid particles can slide over each other, so liquids can flow. Gases have, in the case of gases, the particles are far apart from each other. So gases do not have a definite shape or definite volume. But the gases are compressible, since there are there are large gaps between the gas particles. The particles are quite far away from each other, so gases can be squeezed or they can be compressed. And in the same way, gases can also flow like liquids. So gases also spread out. We can say that liquids and gases both can flow. That's the reason that gases and liquids both are called fluids, because they can be pumped or poured from one container to another. Now, how does volume change with temperature and pressure? Solid, liquids and gases show an increase in volume, which is expansion, when temperature is increased or pressure is decreased, and decrease in volume, which is called contraction, when the temperature is decreased or pressure is increased. And this effect is more bigger or more prominent for gases than solids or liquids. Now, when we say that these particles can, solid, liquid or gas particles, they expand, the gases or the liquid solids expand or contract, it does not mean that the particles increase or decrease in size. Nothing happens with the size of the particles, it remains the same. It is only the arrangement that changes, or the distance between the particles that changes. But the size of the particle remains the same. And in the first one, you can see that if you take any, like for example, you can take gas in a container which is fitted with a movable piston, and you heat it, so the temperature increases. The particles absorb, the particles take up heat energy, because of which their kinetic energy also increases, and they start moving faster. So as the kinetic energy increases, the volume also increases by increasing the temperature. So we can say that volume is directly proportional to temperature. That means that if you increase the temperature, volume will also increase. And if you decrease the temperature, the molecules will lose their heat energy, their kinetic energy will decrease, they will slow down, they will come close to each other. As a result of that, their volume will decrease. And let's talk about the pressure. In the again the this gas filled in a container which is fitted with a movable piston, and there on the top you can see some weights which are kept over the piston. Now if you want to decrease the pressure, so just remove any of the weights from the lid. So here you, in the first one, you have reduced pressure. As a result of it, the piston has moved up and the volume has increased. Now the particles have more space to move around. If you increase the pressure over here, we are just increasing the pressure by putting more weights on the lid. Now the lid will move down. As a result, the volume will decrease. Alright, so it means that pressure and volume are inversely related to each other. If you increase the pressure, the volume decreases, and if you decrease the pressure, volume will increase. Next is changes in state. A change in state is a physical change in matter. These are reversible changes, and no change in chemical composition of matter takes place. So changes in state are just physical changes. No chemical reaction, no chemical process or any change in the structure of matter takes place. It's only the arrangement of particles that changes. Like for example, if you have solid and if you heat it, alright, when you heat it, heat goes into the system. As a result of it, the molecules will gain more energy, their kinetic energy will increase. So that means when their kinetic energy will increase, what will happen? They will start vibrating more. They will start vibrating more and more. As a result, they will need more space to vibrate. Finally, they will overcome these forces of attractions which are holding these particles together. As a result, they will move little bit far. They will just overcome the forces of attractions and they will move away from each other, and we say that the solid melts into liquid. Alright, now if you keep heating it, if you keep heating the liquid, then what happens that again the kinetic energy of the molecules will increase, and finally they will overcome the forces of attractions and they will evaporate. Liquid will change into gas, and finally if you keep on heating it, then the liquid may boil. So evaporation and boiling can happen if you keep on heating the system. The reverse is condensation. That means when the gas cools down. When the gas cools down, then what happens that it loses its the particles lose their kinetic energy, they slow down, they come close to each other, and the gas changes into or condenses into back into liquid. Now if you further um decrease the temperature, then what happens that the liquid may freeze or change into solid state. Now all these changes are just physical changes. It is just in melting and evaporation, you can see in the second picture, it is just the heat energy that is taken from the environment. Alright, heating is done. Solid, liquid or gas, solids or liquids are just absorbing heat from their environment. Whereas in condensation and in freezing, what happens that heat energy is released to the environment. Heat goes out into the surrounding. So as a result, condensation or freezing takes place. Now another process is also mentioned over here, which is called sublimation. So sublimation you can say that there are few solids that do not melt, and when they are heated, instead they turn directly into a gas. For example, solid carbon dioxide, which is also called dry ice, when it is heated it will form carbon dioxide gas. Similarly, iodine is present in crystalline form. When iodine is heated, it changes into gaseous form. So we can say that sublimation is a direct change of state from solid to gas or gas to solid, and there is no liquid state. And remember that just like we know that melting points, boiling points and freezing points, they determine the purity of a substance. In the same way, sublimation also happens at one particular temperature for a pure solid. For a pure solid. Now melting and freezing point. Melting point is the temperature at which solid turns into a liquid. If the process is reversed, at the same temperature, the liquid cools down and turns into a solid. It is then called the freezing point. The melting and freezing point of any substance is always the same. For example, you know that the melting and freezing point of water is 0 degrees Celsius, and at this temperature, at 0 degrees Celsius, the two states, that is solid and liquid, these two states coexist. Now we take the sample. In the picture you can see the sample for which, if, for example, if we want to take the melting point, so sample is taken in a capillary tube and then it is fixed with a thermometer and it is kept in the water bath, and it's then heated. Alright, the temperature will rise in the thermometer and you can read the temperature from the thermometer and it would give you the melting point of that substance. Now we'll talk about evaporation and then condensation and then boiling point. Evaporation is a process occurring at the surface of the liquid involving the change of state from liquid to vapor at a temperature below the boiling point. Alright, what does it mean? It means that the evaporation takes place can take place at any temperature below the boiling point of that substance, and it's a process that happens only at the surface of the liquid. So larger the surface area and warmer the liquid, the faster the liquid evaporates. So for example, if you take a dish like this and you fill it with water, and you can take a flask and fill it with water. Which one has more surface area? Yes, the first one. So that means the surface area is more, so there are more chances of evaporation. This liquid in this container will evaporate more as compared to the second one in which the surface area is less. And the next fact, so the first factor is surface area on which evaporation depends on. The second one is the temperature. That means if the liquid is warm, it will evaporate. If the liquid is warmer, it will evaporate more. The rate of evaporation will be more. The reverse of evaporation is condensation. Alright, the reverse of evaporation is called condensation, and both these processes take place over a range of temperatures. There are no fixed points for these. On the other hand, boiling point is the temperature at which the liquid boils and the liquid turns into a gas. At this temperature, the two states, liquid and gas, these coexist. For example, the boiling point of water is 100 degrees Celsius. So at 100 degrees Celsius, you can see bubbles appearing in water and water starts boiling. In the picture, you can see that the sample or any substance can be taken in a boiling tube or a test tube fixed with a thermometer. Again, from the thermometer, you can read the boiling point of that substance. So thank you for watching. In the next video we will discuss more about the cooling and heating curves and diffusion of gases. So thank you for watching. Please subscribe, like, share and comment.